Today I'm going to walk you through all the tests on JASP that we've done so far. I already loaded in our dark triad data. I don't think that we are using it again in this class, so I'm pretty sure it's safe to just use this as an example to walk through all these different kinds of analyses we can do on JASP. So like I said in recitation and on a couple of announcements, if you go onto our recitation site, you'll find all this data formatted already for you. I've gone in and changed and added the top filters so they're all labeled so that you don't have to do that and you can just get right to the test. All the data is already formatted. Okay, with that being said, the first thing we went over are descriptive statistics. So if you come up here, there's this nice little box here that you can just click on descriptives. It brings over your results page. And here I'm just going to put all three of these things in here. And if you look here, this is valid here. This is where your sample size is. So we have 22,500 samples in our data set. We have our mean, our standard deviation, our minimum number, so the lowest score from all of our samples, and the maximum, so our highest scores from all of our samples, which are kind of scary, dark triad-wise over here. If you go down to where it says statistics and click that, you can now add your median, your mode, you can add your range, you can add your mean absolute deviation. And you come over here and you can see how all these things are now added in as well. So you have your mean, this is about 12.8, your median's about 12, your mode is 10. You see how your standard deviation differs a bit from your mean absolute deviation, which is a little more robust to these outliers up here. So you get a little bit of a different score. So this is where you're going to find all your descriptive statistics. If you pull this over, and one of the reasons I like JASP more than I like SPSS is for this nifty little feature and the fluidity of this application. So I've been an avid SPSS user for multiple years, but when your results page pops up in a different little browser, and then you have to minimize it and do your data and it pops back up. So this is really nice. You can just pull it back and forth and you can see everything. So if I come over here, you see that this is all scale data. This little ruler means scale. If you click on this ruler, you can change the type of data you're working with. So you can change it to ordinal data, you could change it to nominal data. Or scale means it's ratio or interval. For purposes of this, we're going to leave it, but if I changed it to nominal or ordinal, I could then do frequency tables as well. In descriptives, some of your quiz examples or quiz questions asked you to filter out and to look for a proportion or a percentage of the sample. So when it asks you for a percentage of the sample, what you're going to want to do is come over to this little funnel looking thing up here and click filter. So this is your filters options, and all of these should look familiar from either your symbols game or from like kindergarten. So we're going to look at the psychopathy and what proportion or what percentage of this sample are psychopaths. So psychopathy has a clinical cutoff of 30. So we're going to do psychopathy over greater than, and we're going to put in 30. And then we're just going to hit this apply pass-through filter, nice and simple, and you're going to find these beautiful little numbers here at the bottom. So here we have 287 of our data sets or our data points passed through this psychopath filter. If you remember from the examples we went through with dice and the examples Pascal went through with his gears, this is what remained constant. So you know when you have two dice that are stagnant that aren't moving and one die that's moving, or two gears that are stagnant and one gear that is moving, you are going to divide what no longer moved by your total set. So 287 is what remained. So we're going to divide that 287 by our sample size, by our total sample, which is 22,500. And if I remember correctly, we get about 1.27%, so like 1.3% of our sample qualify as psychopaths. When it asks you questions about proportion of the sample, so 1 in 60,000, 1 in 1,000, 1 in 5,000, I know you had an example like that about the dark triad. So when you score above a 30 on psychopathy, above an 80 on Machiavellianism, and above a 20 on narcissism, and have all three of these, you are considered a predator of the worst kind. And that is what the dark triad is, all three of these things combined. So we are going to add in a narcissism score over 20, and we are going to add in Machiavellianism over 80, and we are going to look at what percentage or what proportion is a true predator here through our data set. So we're going to apply all of these through the filter. And here we have 13. So out of all these 22,500, luckily only 13 passed through. Still too many for my comfort, but so from this 13, when it asks you what proportion, you could still divide that 13 by that 22,500. You're going to get a very, very small number because, as this says, it's about 0%. And if you have multiple choice, you can divide all those 1 in whatever through and see what number matches up. Or, a much easier way of doing this, you can reverse your numerator and your denominator and get the proportion. So this now becomes your numerator, your 22,500, and your 13 becomes your denominator. And when you divide this by this, you get about 1,730-ish. And as always, round to the nearest. And since they were all like nice, pretty whole numbers, you would round to 1,700. So about 1 in 1,700 is your proportion of people in the sample who are true predators. We're going to move on to correlation now. I think that's everything I want to show you in descriptives. Remember, though, whenever you're going to do something else, the test, the quizzes, they are randomized, which means that all your questions come in different orders, which is why when I go through them with you, they're probably in a different order than you got them, as well as all the answers are randomized. This is so we have a little more integrity in our quizzes. So everything is random. So if this was the first question you got, you want to remember to remove your filter. So anytime you're done with this and you're done with whatever filters you need, you're going to double click this little trash can. This is going to clear all the filters and put your data back to what you had it as originally. So here we're going to hide the filter. We're going to come back over here and we are going to do some correlation. So you can either X out of this, or you can minimize it. If you just hit correlation, it'll minimize it automatically. So I'm going to go to regression. We're going to do a classical correlation. I'm just going to press that, and it's going to bring up our correlation box. And as you see, it's already here, primed, and waiting for you to put it in your data, in your variables. So we're going to look at the correlation between Machiavellianism and psychopathy. So this might take a little bit because my JASP has been running a little slow. I'm not exactly sure why. I have been doing a lot on my computer lately, but okay. If you see here, Machiavellianism and psychopathy have a Pearson's correlation of 0.35 about. So this p-value here means this is statistically significant. So this is a p-value of 0.001, which means it's pretty significant. So psychopathy and Machiavellianism are pretty highly correlated with each other. If you come over here and you can also do your Spearman's row. This isn't ranked data, so we don't have to, but if you click it, it will also give you, so it'll give you Pearson's and the p-value, and it'll give you Spearman's and the p-value. You see how that's a very different correlation here and there, but this is not ranked data, so we are not going to use that kind of coefficient. All right, so remember anytime it asks you for the correlation between two variables, or it asks you what the validity is of two constructs or two criterion, or the reliability, the interrelator reliability, the split life reliability, or split half, sorry, reliability. Anytime it asks you any questions about reliability or validity, you are going to do a correlation. Now, when it asks you predictions, this is when we are going to use our linear regression. So this is when you have a predictor that you want to find an outcome from. So now we're going to click on, so under regression, classical linear regression, and now you're going to have your dependent variable, which this is your y-axis, and your covariates, which is your x-axis. So these are the outcomes you're looking for. You want to find out how much of this affects this, and this is what we're going to measure. So we're going to put psychopathy up in our dependent variable. So we want to know how much Machiavellianism affects psychopathy, or is a predictor of psychopathy. So we're going to put this in here, and of course, like, we have a whole bunch of information here. If my JASP will just get working. Sorry about this, guys. Okay, all right, so your HO, this is your null hypothesis. So this isn't what we're looking for. Our H1 is our hypothesis. These are the numbers that we're going to be concerned with. So if you look down here at your coefficients, you can see that this is significant. So having Machiavellianism is a good predictor of psychopathy. You can look here and see it is a p-value of less than 0.001. Here we have our Machiavellianism. You have your intercept. And here you have your r squared, so this is the variance. So what this just means is that, and your questions are going to be worded like what is the best, what out of these variables is predictive of something else. So what of x is predictive of y? And you might be given a list of 3 or 4 things to choose from, 5 or 6 things to choose from. What you're going to be concerned with is what is significant here. So anything that has a p-value under 0.05 is statistically significant. Now, when it asks you for beta or variance, you are going to be concerned with your r squared here. So what r squared means is that this is the proportion of the variance that Machiavellianism accounts for in psychopathy. So here we have about 12%. So 1.19 is about 12%. So 12% of the variance in psychopathy is accounted for by Machiavellianism. Not super, super high, but super, super significant. And I believe that is everything that you need to know right now. And we do have you can look at the regression sum of squares, the residual sum of squares, but we haven't really gotten too far into using your ANOVA tables yet, so I will save that for another video for you guys. All right, bye.